Hi guys, all right, I'm going to show you, some visualizations behind complex integrals. So I've made this that you see here using Python, but anyway, this is imaginary axis, this is the real axis in the horizontal, and this is going to trace e to the ix, which is a circle, as you might know. And I'm going to do this from 0 to pi. Okay, so I made this animation, so as you can see, when you click here, you see arrows up here. Each arrow represents basically a complex number from the origin to a point on e to the ix, which is a circle. I'm not showing the circle, just the points, which are again visualized as arrows. So because we're doing this between 0 and pi, the angle goes all the way to where? To pi. Okay, and so I'm using 40 arrows here. I could have used 100, whatever, but 40 are enough actually. So these are the things for each, this is like e to the ix for each x that you input, each angle, for example. Now we take each of these and we multiply by dx, or usually d theta. So maybe think here e to the I theta. So you multiply then each arrow by d theta, which scales its length. Keeps the direction but changes the length. So to visualize that second part, that's what this graph shows. Now notice here it's the same vertical scale. So when you take each arrow and you multiply by d theta, you make each arrow very small. You see this? So the arrows end up looking quite tiny and small. There are still 40 of them. They all point in the same direction, but because there are a lot of them over in a small space, they look solid. But then, you zoom in this app here that I made, they look like this. So one more time, maybe let me reset. So now remember, it's the same direction. There are still 40 of them. They've just been made smaller because each one has been multiplied by d theta. Now you take these arrows and you add them together, and that tells you the integral value. So let's visualize the last aspect. Okay, look, what I'm doing here is I'm taking the arrows, the scaled ones, I'm just adding them together like vectors. The red arrow just represents the sum. When you add up all of those scaled arrows together, look what happens. They're being added tip to tip like vectors. Look what happens. Where do you arrive? You arrive at basically 2, but this is the imaginary axis, so it's really 2i. If we compute the integral of e to the I theta from 0 to pi, you will see it's equal to 2i. But this is geometric intuition behind why it's that. Forget about symbols, because symbols can be meaningless sometimes, right? Pictures are better, more meaningful. So that's it. Leave a like if it's helpful.